Welcome to day 11. Today we will look at the testing of computer programs. Just to digress and let you know how to make best use of this video, 1. You can just watch the video like a TV program. 2. You take notes with pen and paper, pausing the video intermittently. 3. You open up the Python idle editor and type and run the programs. Or you can watch the video several times and do something different each time. It is important to realise you have flexibility and versatility. So testing. What do we mean by testing? Now, testing is not a concept in isolation. You test something. And in this case, we are testing a computer software or a computer program. So you have a computer program which you apply tests on. And in the tests, you are seeing that the computer program is doing what you want it to do, i.e. the output is as it should be. So when you test a program, you run it to make sure it works correctly. And to test a Python program, you run every possible combination of input data and user actions to be certain that the program works in every case. So when you test a program, you don't just run it once with one type of input data, you run it several times with different types of input data to see that the output of the program is as you want every time. And one could say the goal of testing is to make the program fail. Or you could say the goal of testing is to find all errors before putting the program into production. So you test it several times with different input data. And if you find an error, you correct it, you test it again, and you do it again and again until you eliminate all of the errors, and then you put your software program into production. So associated with testing is the concept of debugging, which is the process of identifying and removing errors from computer hardware or software. And in this case, we're dealing with computer software, computer programs. So we could say the process of identifying and removing errors from computer software. Why is testing important? It is important to realise testing is not an academic exercise. Computer programs are written for the benefit of society, so it is important that they function properly. It is important that we test these programs to see that they function properly. The consequences of these programs not functioning as they should can be quite disastrous. A software bug can potentially cause monetary loss or even loss of life. A software bug is a problem with the code of the program. So if we look at some examples here. Example 1. In April 1999, a software bug meaning that the program has not been tested properly, so there is a bug left in the program source code, and this resulted in a failed satellite launch, which resulted in a loss of $1.2 billion, a huge monetary loss. In 2016, an ambulance service in the UK was unable to find a velodrome. A velodrome is where cyclists were cycling for racing and sporting purposes. And the ambulance service was unable to find it because their sat-navs had not been updated. They did not have the right software, basically, or the right data. And this resulted in a number of fatalities. And in 2018, a coding error or a software bug resulted in confidential information of 150,000 NHS patients being distributed. So, software bugs can be both expensive or dangerous, or both. So I can hear you say, quite rightly, why should we bother testing? After all, the programs that we write are not of such importance to society. But ultimately, you will either indirectly or directly be involved in programs which are of great significance to society. So therefore, it is good to get into good habits so we don't make the same mistakes that others have before us. So it is good practice educationally, and it means good habits are being formed now. So test plans. So in order to perform a test, we need to devise a plan about testing, which is called a test plan. Now, it is important to realise in a test plan, there is more to testing than just running a program once. We run the program with different types of data input and look at the data output, and we see that the program is running well and as expected under all the conditions. To test a program, we want to ascertain the correctness of the program after all, so we design and implement a test plan. Design means develop a test plan, implement means put into action a test plan. And the definition of a test plan is a document that specifies how a program is to be tested. You are well advised to memorize this definition. And a test plan has several features. The test plan contains 1. The reason for choosing the data you want to test or the type of test. 2. The data values we test or the test data that we choose. 3. The expected output. And then after running the program or implementing the test run plan, we look at the observed output and we compare it with the expected output, and the expected output and the observed output should be the same. We will look at an example of a test plan in a moment. And test data, we've referred to the term test data, is defined as a set of values used to test proper functioning of a program. You are well advised to memorize the definition. So let's look at an example. Example 1. Write a program which asks the user for their age. And 1. If they are over 18, the program says they can have 10 pieces of chocolate. 2. If they are between 10 and 18, it says they can have 5 pieces of chocolate. And 3. If they are under 10, it says they can have 2 pieces of chocolate. Now, if a negative number is entered, the program reports the age cannot be negative. So you draw up a test plan, like a table like this. So with test number, the reason for the test, the type of test, the input values, the expected output, and then observed output. And we'll leave this column blank for now. So test number 1. Now, in a test, you have valid data. So data which is valid. So data which is within the range, or we call it normal or typical data. So if you input the number 14, the expected output would be you can have 5 pieces of chocolate. For test 2, again we enter valid data, which means data which is within range or normal or typical data, and we enter 20, and the expected output is you can have 10 pieces of chocolate. Test 3, again valid data, data which is within the range, or we say it's normal data or typical data. We use all these words. You should be familiar with all of this terminology and with the term valid data. We type in 6 and the output should be you can have 2 pieces of chocolate. Test 4, we have valid data, but it's boundary data. Boundary data, here input value is 18. You can see 18 is at a boundary. So the expected output is you can have 5 pieces of chocolate. Test 5, valid data again, but boundary data. And we have 10. And it says you can have 5 pieces of chocolate, which is the expected output. And 6, you have invalid or erroneous data. And we've typed in -99, which is a negative number. And the expected output should be you cannot have a negative age. So you can see different types of tests being conducted. 2 types of tests with valid data. And so one type of test with valid data is when the data is within the range or normal or typical data you expect. Another type of test with valid data, but this is with boundary data here, data which is at the boundary. And 6, test number 6, is invalid or erroneous data here. Okay, let's have a look. This is the code for the program, and here is the output. Let us study the output, because that's what we're really interested in. So enter your age. If we type in 14, it says you can have 5 pieces of chocolate. This is the observed and the expected are in tandem. Enter your age, 20. You can have 10 pieces of chocolate. And again, the observed and the expected are in tandem. Enter your age, 6. You can have 2 pieces of chocolate. And this is the output we would have expected. And this is the output we have observed. Enter your age, 18. You can have 5 pieces of chocolate. Now here, it says you can have 5 pieces of chocolate, but what we expected was 10 pieces of chocolate, so the output given and the expectation are different. Enter your age, 10, you can have 5 pieces of chocolate. Again, output given and expectation are the same. Enter your age, -99, you cannot have a negative age. Output and expectation are the same. Enter your age, 99. Now this is not on the test plan, but if it was on the test plan, we would expect the program to say for output, you can have 10 pieces of chocolate, and that's what we do get for the output. Now, if we look back here, where the expected and the output does not match is here. Enter your age, 18, you can have 5 pieces of chocolate. It should say 10 pieces of chocolate. And if we go to the code here, it says if age is greater than 18, you can have 10 pieces of chocolate. We should correct this to say if age is greater than equal to 18 and print you can have 10 pieces of chocolate, and then this will be correct here. So now we have corrected the program, and you can see here it says if age is greater than equal to 18, print you can have 10 pieces of chocolate, and we have run it. Enter your age, we've typed in 18, and the output is you can have 10 pieces of chocolate. So we've corrected the program and it is fine now. Now, really, when you correct this, you should actually run it for all the test cases as well, to make sure that you haven't inadvertently affected anything else. But for the time being, we'll just run it for this case, and we can see that this is now corrected. Last but not least, what you do is you take this test plan table again and you fill in the details of this observed output. And you can see here, after we have filled in this observed output, all the details, the observed output in each case matches the expected output. So we can say that we have a very good working program. Thank you.